Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk, I got a trick question for you.
Uh-oh.
Yeah, you brought it up near the end of our last episode, and I thought, oh, that would actually make a cool topic.
Okay.
So if somebody asks you in an interview, can you pass halt?
Yes, that would be a revealing question, because obviously you can't pass halt. Halt is an evaluation. It's not a pass-fail test, and there is no pass-fail to halt. So
Right.
That's a simple answer.
It's a simple answer, but the idea is that, to me, if somebody asks me that question, either they're trying to they didn't read my resume, they don't know who I am, right? And either they have no idea what halt is, which is dangerous in an interview, to assume that your person you're interviewing with is an idiot. It happens. Sometimes they are. And I say, I'm not working here. You don't know what you're talking about. And I'm not doing stupid stuff, and I got up and walked out. And so I'm not going to waste your time interviewing me further. I'm not going to work for you. You don't know what you're talking about.
Right.
More often than not, it's an opening question, and it's not always just, can you pass halt? It may be a question of, well, what is your depth of knowledge of this? Do you really know what you're talking about? Or stuff like that. It's more a question to say, do you know this? As opposed to, do you know anything? Because if I ask you, do you know about halt, how to do halt, HALT? It's a yes/no question. There's no discussion.
Right.
Right. You say yes, and they'll prove it. And then what's your evidence of that? Tell me about it. And you either you know it or you don't, and become clear pretty quickly. So that's a technique, is to understand that. But some people shortcut it and say, can you pass halt? And I've had somebody say, oh, yeah, absolutely. We never fail that test. And it was the supplier I'm talking to. You don't know what the hell you're talking about.
Right. Or even doing it a little more sideways, like, how do you pass halt?
Yeah.
And I go, okay, and obviously, if they ask that question, well, that would be a good indication. You're assuming, when they say anything, ask you about halt, that it's a general knowledge that people know about halt. And I've gotten so many different concepts or people saying, oh yeah, we do halt. And then I ask what they do. Oh, and then they say, well, we stop at 80 degrees because that's good enough. ADC, because that's good enough.
Well, you're not doing it then.
Yeah. So you think you are, and you call it that, but it's not that. So, this is a problem, is the different understandings of it. And also they think, well, it's just vibration and thermal, cycling or step
you just
stress.
Get a chamber. We got a chamber.
Going,
we have a chamber. We do halt.
You can do halt. You can do halt without a chamber and without any, you can voltage. You can do frequency. You can do, different things.
Some parts of the country, like your part of Colorado, you just put it outside any day of the year, and it'll get thermal cycled 15 times.
Yeah, it's true. It's quite extreme here, but it's all
right. So that's just one trick question.
Okay.
What other ones have you run across or heard about? That are like, do they really know what they're talking about, or is this just a test? Kind of thing.
Well, because I guess they'd ask something about MTBF, and that would be that would be your favorite question. Yeah. Tell me the meaning of MTBF, and how that helps you improve your reliability process.
And then they say, but our product is not repairable. So, you really should have answered the question for mean time to failure instead. I'm like, oh, okay, you're so proud of yourself.
Yeah.
Have a good time.
MTTR,
Ooh, yeah.
Oh, come on, people. And this is the kind of thing that we would say, well, this is not a good fit for me because I would have to do so much convincing and
Re-educating of your,
re-educating, and that really has to start from the top. So unless you're in an executive, almost executive position and
you're
directing
willing to
downwards,
change.
my biggest success in that field was when I was hired as a consultant for advanced energy back in the
Hmm.
80s and early 90s. And I talked to the president for about an hour and a half. And he was an engineer, which made every difference in the world that
Hmm.
he could understand. And he had actually designed and built these power supplies. And he'd actually worked in this company early in the development. Now it was a, 400, 500 person company, but
Hmm.
he understood what he was saying. And we looked at his failure analysis reports and they said, yeah, this probably would be a benefit for us. And it did. It reduced their on the one product that they had already been producing for 2 years, it reduced their failure rate from 5% to 0.5%. It
Wow.
did. It did cost them something. It cost them chambers and Haas and
And some design changes.
design changes. Yes, and so that I had a record. Now, that one of the problems in our field is you can't carry that record very well to another company because you're locked under NDAs.
Yeah.
So you may have success, but it's
You could talk about it like you just did this now and say, so you give that president as the reference and they can call him up. So did he actually help you make this change? Yeah, he did. You know?
yeah. Well, if he's still around.
Yeah, well, there's that. But I mean, there's the question of, I mean, there's other trick questions. MTBF would be a good one. It was like,
Yeah.
and there, I definitely think they don't know what
Boy.
they're talking about. But it's just my bias and immediate on
Well,
that.
sure. And I'd say that's silly. You don't understand NPF if you think it has is a good indicator of your reliability, you know.
Yeah.
You just
And that one I would expect, but anybody that actually looked at my resume would go, "All right, we better not." I had somebody walk up in an airport once that I was heading to a conference, and they said, "So, you're Fred, right?" And I go, "Yeah." And he said, "So, what do you think about MTBF? I've been really curious." He started laughing. He had a no MTBF button on his shirt.
right.
He
Yeah,
opened his
yeah,
coat up and
yeah.
showed me his
Yeah.
button.
Don't don't sugarcoat it, Fred. What is your real feelings about
That's right.
MTBS? Yeah,
And
that was your
but
first website.
there's a, it actually was second, but yeah, pretty close. The
Oh,
first one.
okay.
Yeah. But the idea is, uh, oh, what package do you use for reliability prediction? Or, like, okay.
Yeah, exactly. Use FIDES, use Mill Handbook 217,
Or
you
do you
use the
combine them in some awful way that nobody really understands, you know? Um,
and why do you believe, and have you seen any correlation with your predictions in the past to what is actually happening in the field?
Another one is, um, when I ask people, so what happens when something fails? And they say, we isolate the component and send it to the vendor. And so it's not a trick question. When I ask them, is that, do you get useful information back from the vendor? And they all look at each other going, no.
Yeah,
Okay. Then why do you send it to the vendor? It's because we don't want to take the time to figure it out.
that's right. Yeah. Yeah.
No, it's not a trick question, guys. Don't just, you need to understand failures. You need to do the lab work. You need to get a good, if you need an x-ray machine, go to a lab that supports that
Right.
and has that equipment.
Yes,
Hire them and
there's a
get
lot of
access to
good
that.
independent failure analysis labs that do a very good job. I've had them right here in the Denver area,
Yeah.
and can do cross sections of decapsulations. They can, and they're very experienced in it. And
And material identification, they can tell you this is good intermetallic layers of bonded
right,
well, or is
right,
it this white powder is bad or good for your product, or
exactly. They've probably seen it in other products that they've dealt with,
oh
especially if
yeah.
they're independent. They're dealing with a lot of different companies and different products, components and things like that.
Yep.
So that's they have a very good general knowledge, and I would definitely um, trust them over the actual component manufacturer because He doesn't want to be blamed for anything, and he doesn't know your system. He doesn't know, how many places where you use this component, or how you use this component, or the supporting surrounding circuitry, and what could be in transients that he has no idea that you
Hmm.
had, and you had no idea that you had, because you haven't looked at the
The
function of.
system, yeah, the
Yeah,
in
you haven't
context of
done
where it's
anything
going.
to really analyze what the potential causes of this failure is in situ, in the circuit, in as it's operating. Like, because I know that there's a lot of times there's transients, there's uh, motor feed, I guess, coil feedback, from a like a
Well,
solenoid
induction molding,
coil.
there's all kinds of
Like, right, they
things
can,
that are going on that
right, and
happen.
they're very fast. Sometimes you can't even, they take
They have a really
almost
good oscilloscope to
a
detect
really
them.
fast oscilloscope to see these things, but they can be extremely critical
It can be very
causes of.
damaging.
Right.
Yeah. Oh, one of my favorites was walking through it was an engineering lab. It was the design team's labs. And there's
Mm-hmm.
all these bare circuit boards laying all over the place.
Yeah.
And I like, don't you worry about ESD at all? Kind of mucking up your, ability to get your prototypes here to work. And they go, we think about that every now and then, but we haven't done anything about it. And it says, do you have problems with your boards not working? Your
Yeah.
chips? Oh yeah,
Do you notice
we
that
have
little
to.
spark between your finger and the board?
Yeah, and it was, and they had tables that could have been grounded, but they weren't. And I'm like, they only work if you actually use them properly. And they had a whole bin full of boards that they knew didn't work anymore. And they were swapping them out until they found one that worked and damaging them as they go. It was amazing to me.
Right. Yeah. You see that
But
in repair
but you hear
shops.
that in everywhere. It's like, oh,
Right.
that'll never happen.
Right.
Well, that'll never happen.
Now up here in very dry Colorado, it is ESD was a
Even at
significant
home.
problem at Storage Tech. We had fabrication board assembly lines, and also they control the humidity in the room to
Hmm. And
help
probably
reduce
had
that.
lotion to keep your hands conductive.
Exactly, exactly. And you always had a ground strap on your leg to the floor or whatever.
Yep.
And so yeah, that's kind of one of those hidden damaging stresses that is hard to see and may not be realized by those that are not aware of what ESD damage, how it happens.
Oh, and it took a conversation with this director of engineering. It's like, you realize that those 100 boards are prototypes and they're not cheap. Oh yeah, tell me about it. We can barely budget to get enough to even do anything. And like,
Yeah,
then stop destroying them. Just stop it.
yeah,
Kind of
yeah.
thing.
So
And there's some circuits that are fairly immune to it, but they had
right.
very small microprocessors on these things and very, small gate sizes and all this. I'm like,
Right, and then there's ways to build in protection onto the board to keep
there
that from
is. They
being a
didn't have any
problem.
space for that. I
Right,
asked about it.
right,
They had nothing. And like, you're plugging in a cord under this thing that's full of charge, and
right.
yet no protection except on the chip. Yeah, that's just asking for trouble. But that
Right.
was one, is ignoring problems, and it's the same. Oh, the customer would never use it that way. It's like, okay, this is not a trick question. This
Yeah,
is, what are you talking about? Kind of statements.
yeah. How do you know that?
That's right.
Why are you saying that? Because I guarantee people will use it lots of
What?
ways that you never expected
That's
and
right.
planned ahead, because you don't see that. You only see the immediate, the first years of use when uh, people have gotten accustomed to it being pretty robust in that application. And then they stress it to putting it on their boat, or they put it on,
Yeah, they move it to another location.
attach it to the top. I don't know.
Yeah.
They're different places, but they get comfortable with its operation if it's reliable, and start using it in more harsh environments. I mean,
Well, it just made me think. I saw an ad for like the early, I think with Model T, or even vintages about that time frame, early
uh-huh.
1900s kind of thing.
Hmm.
And there weren't really that many paved roads, right? There is, so these cars were bouncing along and
Oh yeah,
potholes and all that other stuff. And
pretty rough stuff.
yeah,
Yeah.
and now you have to buy a specialty car to go off road. So we haven't gotten any better. I'm just thinking about that.
Yeah. Well, right. And but I think that, we've got more technology that can transform cars. I think you have different driving modes and cars that you can program in and sporty. I don't know. Suspension, things like that. I know that there um, settings for some cars
For
that
some,
you
yeah. Yeah. And you can put it in or out of four-wheel drive with a push of a button. There's
exactly.
kinds of
And
cool stuff
you
nowadays. But
know, don't you have active uh shock absorbers too? I think, or you can have just like we have noise canceling headphones.
well, you must
I
be
thought
driving
those.
some expensive cars.
I looked that up. I think they have a feedback system for active uh shock absorber.
So
Active.
as the bump starts, it
Yeah, yeah,
takes the
yeah. They
bump out before it hits the
Well,
car.
right. It can do the opposite, just like we do with headphones, where
Hmm.
you're actually taking in the sound wave and forcing a 180-degree out of phase, exact opposite wave hitting that, so it's silenced. They zeroes out,
Sure
right?
is a noisy way to silence stuff, though.
It is, and some people have complained. I'm not bothered by it. Um, but I definitely have a couple of noise canceling headphones, and they work quite well.
Yeah, no,
I
I
can
get
really
that.
tell.
Uh, it the the idea is that reliability in identifying trick questions or what are you thinking kind of phrases,
Yeah.
they happen. It didn't take very much thinking to come up with all these examples, and there's dozens more, I'm sure, if we kept this recording going a bit longer. The idea is that you need to know enough about reliability engineering and just good general practice engineering in general
Hmm.
to identify those. It's and say, now wait a second. I don't do we really know how our customers going to use this? Do
Hmm.
is what do you mean that we're only using MTBF because that's good enough? I hope nobody has that problem.
No. But I have asked a job candidate about MTBF, and they said as soon as they start rattling off,
All the
I
good
just,
stuff about it, you're like,
yeah, I
we got
just,
to work on this.
oh man, this is not
But
going to
it's,
go
the
long.
suppliers will never send you bad components. Okay. It's kind of a problem
Yeah,
believing that.
they'll never.
You just,
Yeah. Oh, it was our fault. Yeah, we made a bad one. Here,
yeah,
here.
here you go. Here's a new one for you.
Yeah,
Two
here's a
cents.
new diode.
Yeah. But the idea is that there's, and I think this is true in every engineering field. There's misconceptions, there's ways we've always done stuff, there's all
Right.
kinds of practices out there that with a little bit of scrutiny, you can add a lot of value. You can actually make improvements. Those are sometimes they're cues to say, do they really know what they're talking about? Maybe this is more of a training challenge than a engineering challenge. And other times it's a way to probe to somebody know what they're talking about. And I think we talked about both of those scenarios.
Hmm.
But in general, is you need some fundamental knowledge about reliability engineering, preferably through experience, to say, yeah, things like this do fail. And if you use it in Colorado near where Kirk lives, it's probably
Hmm.
going to fail. A little bit of common sense goes a long way. And part of it is understand what's behind the question or the phrase or the statement. And sometimes they're absolutely true. And for that circumstance, environment, product, and so on, that's the way things are.
Yeah.
Yet if you don't get a rational, verifiable explanation of why that is true, well, then it's just conjecture. It's just fantasy. It,
Right.
your opinion is as good as mine until we have the facts, and kind of
Right.
thing. And
Right.
part of reliability engineering is asking those questions and understanding it at a fundamental level. And I think that helps you navigate all these weird things that people say and believe or understand, or that's the way we always did it. kinds of things so that you can identify where you can actually make a really big impact and improvement or make some changes for the better for everybody. Those kinds of
Yeah,
things. So,
that can be a daunting task though.
oh yeah,
You know,
no doubt it
generally
is.
I'm cutting against the grain when I talk about using testing to limits and testing
Mm-hmm.
to extremes that'll never see in its in use environment. And they go, "Oh no, that you're going to give us a bunch of irrelevant issues that we're going to go chasing on that don't mean anything in the field."
Right.
And that's it's just you, you've got to either enjoy the battle because the victories are few and far between. I have had
Well,
some
now you
great
make it
ones.
sound pretty dismal.
Well,
And you wrote the
if you
book
want to
on
be a
this.
change agent, and that's what I did. I don't want
Yeah.
to come in there and say, "Oh yeah, I'll do these MTBF calculations for you," even though I have. And I have done predictions for companies just because I need the money
Mm-hmm.
and just not to fight the battle, and to argue with the guys that say it'll never see that as in use environment and try and convince them that that's not what I'm trying to do.
Mm-hmm.
And so it's whether you you need the job sometimes you got to take it. I'll do the predictions for you even though they're meaningless. A lot of people do jobs that they have to survive, and then look for the jobs that you can actually go make a difference and that are open to change. And uh, definitely at Dell, it was very useful, especially during the transition of lead leaded solders to lead-free solders. They
Mm-hmm.
found that extremely helpful. So those techniques are still used today, and I think Huawei is probably still using those techniques. I don't know, and you won't know, and nobody will know because it's all hidden. You know, that's company proprietary. Just like
Well,
when
what
I
was there was an ad, I think we even talked about it. And I know I talked to somebody. Was one of the, was it a Samsung folding phone? And
yeah
they showed the test device folding it in and out.
yes
And
yeah
then the first ones got out there and they folded it 3 times and it would crack or it would have
yeah
a line through it.
yeah
It's like, yeah, you don't see behind the scenes life testing type stuff very
no
often in advertising,
no and
especially after that just failed.
well, I'm curious to see how folding phones will do. They look like a good idea, but again, folding anything is a mechanical cycling S-end curve, and it eventually will fail.
Yeah, no, it keeps us in business, doesn't it, Kirk?
Yeah, I guess so.
Oh, trust them. It's never going to fail. We tested it.
Yeah, and even
Okay.
well, the problem is those foldings tests that I've seen are, they've got a little machine that collapses and holds it
Perfect pressures
perfectly
all the way
every
across.
time, right? Nobody dropping it on the ground and then folding it. Nobody's
There's no
putting it in
dust,
dirt, dust,
paper clip.
paper clips, right? Folded under, pants, whatever uh, and sideways torque,
Hmm.
between the on the hinges.
Oh, but that'll never happen. Tell
Yeah,
me about it.
right.
Nobody will do
Yeah,
that. It's too expensive.
right. Or what's open, the drop testing, how many times they do it what's open, how many times they do it's closed, how many times, anyway,
Yeah. But
that's
the
all
idea
secret.
is that there's all kinds of stuff that we can learn and do. And sometimes the way people talk about reliability engineering is used all kinds of different ways, but it's also a clue for us to, learn something and to transfer knowledge that we have and stuff. You need some basic knowledge to get these ones. But listening to
Yeah.
a few of these episodes, hopefully it picks up. Your knowledge will be exponentially improved, and that's our goal there.
Well, we're trying to spread the word, and definitely you give especially with Extendo reliability, give a wide spectrum of the issues in either product development or in plant maintenance and
Hmm.
that kind of thing, which is way after market.
Yep.
So it's been, I mean, this is really a very comprehensive website, except for site reliability engineering, which hopefully someday you'll get somebody to put an input.
Yeah, I got to find a good candidate for that. But anyway,
Okay.
if you're listening to this, if you catch on all these phrases and you understood it, maybe laughed a little bit. But if you have a few other phrases that we missed or didn't bring up, that'd be cool to hear about. What's your favorite catchphrase or trick question type thing? We'd
Right.
love to hear from you. Head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. Kirk and I and the other hosts are available through LinkedIn and our About pages. So plenty of ways for you to get in touch. And we always enjoy hearing from you. And we look forward to your questions and ideas and suggestions for future episodes. And with that, Kirk, I haven't seen a folding phone, and I'm not going to go out of my way to go find one to play with at the moment.
When I look at a folding phone, what I want to look at is that crease where it folds.
Yeah.
And see how, it's going to get distortion a little bit after a while. And I imagine, I don't know what polymer, is it glass that they're using?
I have no idea. I'm curious,
because we know polymers scratch and things like that. So I'm curious
glass
too.
Doesn't fold very easily.
No, it doesn't. So it's got to be some polymer, and whether it's scratch resistant. That was the thing about Gorilla Glass. It was so strong.
Yeah.
Now it's gotten incredibly strong.
Yeah.
But we'll see.
All right. Have fun, Kirk.
Okay. Thanks a lot, Fred.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.